synchronization. So it's not the race condition. Race condition always the multiple process. They concurrently are accessing the shared data. That causes the problem. So it depends on which process finishes the last, and it will be the different. So to understand do you remember that when we talk about the process, we are going to model of the computing the processes as the producer and consumer. This is kind of the modeling. So we can understand we are going to use producer and consumer problem for the race condition, synchronization. This producer and consumer used a lot in our computing environment, like the client and server. It's a producer and consumer problem. And the other process, the generating the data, and the other process reading the data is also producer and consumer problem. We will see some other example of the modeling later. Philosopher and philosophers.
Dino philosophers.
Yeah.
Dino philosophers.
Yes. So we will see dining the philosopher problem, and there are different types of the model. All of these are causing the synchronization. So because producer and consumer problem, we have the buffer, and the consumer read the buffer, and we are sharing such a data. So first, this is a very simple and typical problem of the synchronized race condition. So we have the shared data like this. Okay, let's say this is a count. The current value is, for example, 4. Then we have 2 CPU. CPU 0, CPU 1. Let's say CPU 1 and 2. Sometimes it's confusing. CPU 1 and 2. So same time, they are accessing the same data. This is CPU 1 plus. Okay? This is CPU 2 minus. Okay? So when we have the 4, in case we have a single process, it's not a problem. Why? Anyway, at a certain time, only one process is run. But when we have the 2 processes, what will be the output? It can be 4, it can be 3, it can be 5, not 6. How can it be 6? Possible? If you learn the 2 times. So just 1 time. So it can be 3, 4, 5. For example, if this one is read, okay, at the same time, this one is read. Both of them are 4. Okay, then the increment will be 5. Decrement will be 3. Then update this one, so 5. Then update this one, it will be 4. Okay, then vice versa. It's also the 4. Also, this one read the data and update. So this one first, it's a 5. Then next, this one, it will be 3. Okay, and vice versa, it will be 6. So this is caused by the race condition. This situation is called the synchronization or synchronization issue. So this is an example of the counter 2 processes. Okay, so one process is increment by 1. Another one is the decrement by 1. Then there are 3 different cases that I explained. Okay, in terms of the what is that? Instruction, it will be like this one, but for your better understanding, you can understand using this high-level code. So first case, I already explained, finally, it will be the 4. And the second case, it will be the last one, will be 6. Which one will be the last? And or it can be the 5. So there are different possibility. So this is called the race condition. Okay. So how can we solve the problem? So we are going to define the critical section. Critical section means so we have the sequence of instruction. This is a process, the instruction. Then at certain part we are going to read and update, manipulate the shared data. Okay? If you do not access, if you access only the non-shared data, process specific data, it's okay. You can do whatever you want. But at certain time, the instruction need to access the shared data. This part is a beginning and end, and this, the group of the code is called critical section. So we are going to define this one is the critical section. Then, if you just before you realize that I need to access the shared data, which means I'm going to enter the critical section. This is called entry section. Entry section. And after you out of the critical section, you no longer leave the critical section. This is called exit section. So we are going to model the process entry section, the critical section, and entry section. So we are not going to change it, the process. Instead, from the operating system point of view, we are going to model. Consider this portion is entry, this is a critical, this is a exit section. Then problem is whenever a process enters the critical section, we need to do something. That will be the solution of the synchronization. Otherwise, the other part will not be problem. Okay? So this is a model of the processing. Okay. So critical section is the portion of the instruction that would like to access the shared data. Before entry section, after exit section, then remainder is all the other. All the other will be remainder. Okay? Then, what will be the main job of the entry section? You need to inform to operating system. You need to inform to the other student. I'm going to use the post-it, share the data. You are not it's not your turn yet. Okay? It's not your turn yet, but you need to express the intention. I'd like to use the shared data. Then, if you are selected, then you can use. Okay? That means enter the critical section. Sometimes you need to wait until the other student return the post-it. Also, even though available, because there are many students who are waiting, then we need to vote. We need to select. The main job of the entry section is inform to the others. Then operating system need to select one of the process to enter critical section. Exit section. When you are done, you need to return. I'm done. You need to inform to the other student. I'm done. Then the other also operating system no. So there's no more process for this critical section. Then vote for the next one. Many of the time, I'm using the example of advising or going to the bathroom. How many bathrooms? We have only one bathroom, but how many students are waiting? Many students are waiting. So we are going to solve such a problem using this model of the process. Some of the students, when I'm doing my program language, I never did such a thing. I never used the entry section. No, you don't have to. Who is in charge of such a thing? Operating system consider your instruction code when before read or write, before you do something, share the data, okay? Then run the entry section code, okay? You don't have to code by yourself. Then when this part is done, then operating system do the entry section, exit section code. Then this is your code. You don't have to. But in your application program, it's not operating system, application program, if you are creating multiple threads and multiple processes and reading data from here, you can make your own code for the synchronization. Algorithm is the same thing, but implementation, in your the program, you don't have to. However, if you need a synchronization solution in your application code, you need to do that. So there exists always system library. You can use the system library to serve the such a synchronization. We will see the example of the pthread later. Okay. So this is a simple example of the entry and exit section. So for example, this part, whatever that is your code in your application. Critical section, accessing the shared data. This is the other, non-shared data access. Before you enter, what does it mean? Ton is equal to Z. It's a PI, code of the PI. Okay? If ton is equal to Z means another process is using. Is it true or false? True. Okay? So can you enter the critical section? No, because it's a while the infinity loop. Okay? It's an infinity loop. True, 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 true. Until when? How can you get out of the while loop? Process J. When process J out of the critical section, it will be turn I. Okay, this is the process I. There will be process J, another process. Process J, current process out, then it will be turned into I. So turn is equal to I, but I is equal to J. Is it true or false? False. So you can enter critical section. Then when you out of the critical section, turn equal to J, and another process can enter. Don't worry. So this is just a simple example of the synchronization, which is not used. It's very straightforward and but easy, but practically it's not used a lot. It's just basically locking. For example, when we have two students, okay, we have one bathroom. So if someone is used, A is used, then whose turn? It's A turn. Okay, A turn is A, other. So you cannot enter. Okay, when the A student coming out, then change the turn to other, I. Then the B student can enter finally the bathroom, enter the critical section. So that's the idea of, if you can understand this one, we are going to see several solutions. So before we discuss, there are three different types of the solution. One is the software solution. Software solution means the solution of this kind of algorithm. Operating system implement such a logic in their kernel code. Then they manage this kind of critical section. Second solution is a hardware solution. Hardware, what kind of hardware? Lock and instruction. Instruction, who provide the instruction? Operating system, processor, CPU, vendor. So which means it's a hardware. So using such an instruction, we can do the hardware. Operating system is using system library, like the swap. Swap is the something library, and swap is actually this one. The operating system provides something data structure. System library, the data structure like the monitor and so on. So using the operating system solution, you can solve such a problem. We will see each of them after we define the requirement of such a synchronization in the next class. Okay. One more time. The Thursday we will have the exercise lab with the briefing of our project, and the project view is extended to the next week of Friday.